Alright, so in this video we're going to go over redox reaction. Now, redox comes from reduction and oxidation reactions, and that is what we're going to go over in this video. Now, first of all, what are redox reactions? Well, they are special reactions that occur when there is a transfer of electrons. This may sound familiar because transfer of electrons was mentioned when we're talking about ionic bonds in terms of ions. So it's similar to that, it's just a matter of what's happening to the entirety of the reaction. Well, these redox reactions, they are split into two half reactions, and they actually cannot exist without the other. So they have that relationship where one has to rely on the other. And so oxidation involves a loss of electron, and reduction is the one that involves a gain of electrons. From here, what we have to understand is oxidation involves a loss of electrons. So when it loses that electron just can't disappear into thin air. It has to go somewhere. But where does it go? Well, whatever is going to be gaining those electrons ends up being what's being reduced, because the reduction is defined as something that involves a gain of electron. So notice that one can't exist without the other. All right. Now, in these terms, you have to keep in mind that always when we deal with oxidation numbers or dealing in terms of loss of electrons or gain of electrons, you have to realize that electrons have a negative charge. So when you lose electrons, you're getting rid of negativities. So in terms of oxidation numbers, which we're going to go in a minute, your number ends up actually going higher up. You become more positive. This is the same concept of becoming an anion or a cation. The more negativities that you get rid of, so more electrons that you lose, you become more positive. So the number goes up, and vice versa for the reduction. So basically, oxidation originates from the fact that the word oxy comes from the word oxygen. And initially, it was thought that these reactions had dealt with the combination of oxygens. But later on, it was evident that it wasn't actually the oxygen, but the electrons that were involved in there, that were losing it, that was creating these types of reaction. So a prime example we can notice over here is sodium. When you look at sodium, atomic number 11, it has 11 total electrons. You look at the number of valence electron, it has one valence electron. So let's look at the entirety of the sodium atom. It has 11 electrons. It also has 11 protons. That means the charge is 0. Now, let's talk in terms losing electrons. So if sodium were to go through the process of oxidation, then what is to happen is that it will lose an electron. Notice when it loses an electron, it becomes more positive. So in this case, we can easily refer to the fact that because it started off as sodium right here with 11 electrons, and then it ended up losing that one electron that it lost over here, and we have this sodium right here. So we can go through the process in saying that sodium was oxidized into sodium ion because it technically lost electron numbers. So the total charge for the original sodium right here is 0, whereas the total charge for the sodium right here becomes +1. So in terms of what we call these, well, in terms of charges for now, it went from 0 to +1. So it went up. That indicates that the electrons were lost. All right. So let's look at reduction then. Reduction also vice versa works the same way. When it gains electrons, notice that originally it has 2 chlorines, but the total charge is 0. But then it ends up with 1 negative, but 2 in total, which means that it had to gain 2 additional electrons in order for that to happen. So when that occurs, we call that the chlorine became reduced into chlorine ions. All right, so it's a matter of trying to figure out what's going on with those charges that we're seeing right now. But those actually have a very sophisticated name, terminology for that. Instead of charges, we now actually call these oxidation numbers. And these are extremely critical in redox reactions. These are what tell us and define us how the reaction works and which ones are going to be oxidized or reduced. All right, now, you have to keep in charge that charges and oxidation numbers are not necessarily the same thing. we have to keep in mind that charges are a physically real characteristic, which means that charges exist because electrons are either lost or gained. For an example, sodium is always going to have a +1 as a charge because that is a physically real characteristic of one electron being completely lost or given up and has that +1 charge. Whereas oxidation number is more of a number that we assign so that we can keep track of the overall electron distribution, so that we can get the math correct in a sense. All right. So when it comes to determining oxidation numbers, there are several different rules. And we need to know these because by assigning oxidation numbers helps us determine, and this is where we're going to learn these rules in how to determine the oxidation numbers. All right, these are the ones that help us determine what becomes what. All right,